2 under algebraic processes is a simultaneous equation. It says solve the simultaneous equation. 3x is equal to minus y. This is the first equation. And y is equals to x plus 4. X plus 4. Okay, now I can label the equation. 3x is equal to minus y. I call it on equation 1. And then I have y is equals to x plus 4. I call this equation 2. So I've named the equation. So I will easily use substitution methods for this one because this one already is a certain formula. So I say from 1, equation 1, y will be equals to minus 3x. Why? Because this minus will come here. Okay? So I will now say substitute, I can call this equation 3. Substitute equation 3 in 2. So wherever I see y in equation 2, I put minus 3x. So I will rewrite equation 2, y is equals to x plus 4. And this y now becomes minus 3x by virtue of the fact that y has been defined by minus 3x before. So it's equals to x plus 4. Collecting like terms, so minus 3x is equals to minus x. Why? Because x will go this way as it's coming over the equality sign, it becomes minus, is equals to 4. Okay, so minus 3x minus x will be equals minus 4x is equals to 4. So at this point, I can just divide both sides by minus 4. So minus 4x over minus 4 is equals to 4 over minus 4. Cancel, cancel. S is equals to minus 1. So if s is equals to minus 1, what is y? What is y? So we see we are going to get y. Therefore, y is equals to minus 3 into minus 1. Y will be equals to what? 4. So there are two solutions. X and y is equals to minus 1 and 4. That is, x is minus 1, and y is 4. If I put any of them here, I will get my solution. So this is not 4. This is 3. Please, this 3. I quickly did what's it called? A check. How do we check? Just put these two values here. If the equation is true, then you are correct. Okay, so minus x is minus 1, right? And y is 3. So if I put 3 here as y is equals to, if I put 1 here, will it balance? Yes. So this is the answer. This is the answer for that question. Okay, go to the next one. So I have on the board, say factorize p minus bq plus q minus bp. See, I said in that first video that algebraic process has to do with letters and how to factorize or add or solve equations. You have linear equations, you have quadratic equations, you have simultaneous equations. But today we are looking at factorization of this expression. The first thing we do is to try and collect like terms. So I have p, and the next way I have a p is this last term, so minus p bp. Then I said minus bq plus q. So this first two terms I have a p, this last two term I have a q. So I can factorize. I will look at the common term. So these first two terms I have p as common. I bring p outside. So if I do that, p into this first one is 1 minus p into this second one is b. Okay, so I can, at this point, I can still go back to this place by expanding. P times 1 is p, p times b is bb. So I'm okay here. So minus. So what's common here? What's common here is q. So I put the remaining ones, b is here, then plus 1. Okay, well, I'll make it minus 1 because of what is happening outside. This is what is affecting me, so minus 1. So what, at this point now, this where I am now, I can still go back to this place. Why? Because b plus b times q is minus bq, you understand? And q times minus 1, that's minus q times minus 1, is plus q. So anywhere you are, you understand, every stage you get to the next stage, try and see whether you can go back if you expand. So this is true. So if this is true, I can now factorize by grouping. I can group this and this because they are the terms outside the bracket. But this and this, I have to do something to this sign so that this thing can work. So what can that be? What can that be? Okay, so just hold up. Okay, I cannot take, because this and this are different, so I cannot take it as a 1. So I will have to introduce a minus sign here. So yes, so what we will do here now is that we will take this and this as a common factor, B and P and Q as common factor, and we will take this one as a common factor, 1 minus B as a common factor. Why are we doing that? Because this one, the minus outside, is making this side look like this side. See, minus times B is minus B, which is this one. Then minus times minus is plus, which is this one. So I'm taking this one outside and I'm taking one of these two, which is this. So the answer is bracket open P minus Q, bracket close, open the bracket again, 1 minus B, bracket close. So the answer is A. Notice that even you see that one other one, I'm having this one here. Okay, so see, everything looks almost the same, but except for the signs. So be very careful when you are choosing your options. So go to the next question. Okay, so still on that algebraic process, we have a question on the board. This is a clear case of substitution. It has that if m is equals to 2 and n is equal to minus 3 and p is equals to minus 2, evaluate. This is what you are going to evaluate. So this is just a clear case of substitution. Wherever you see all these letters, you put the values there and you compute. So we're going to start from this term here. M is 2, so when we see m, we put 2. So I'm writing it out like that, 2. Then n is minus 3, so I open my bracket, I put minus 3 there, all square. That's this what's happening. So this is this. The minus p is what? Minus 2. I open bracket, minus 2, and close bracket, all square. All over. Then there's a 2 here. Just follow it 10 by 10 and substitute. N is minus 3. You see? The bracket means that you are multiplying. Okay, so then they say P again. P is minus 2. So I'm done with this particular term. I put a plus here. Then M is 2 all square. Then over 2n. N is what? Minus 3. And P is what? Minus 2. So just watch. This and this are the same thing. What I have here now in numbers, the same thing we have here. Why? The difference now is that I just replace the letters with whatever they say we should replace it with. Just do it carefully, you will not get it wrong. So the next thing I come to do here is that I will put my 2 here, this 2 here. Then this one, if I evaluate it, minus 3 square is minus 3 times minus 3, which will give us 9. So I still put 9 in brackets again. Then minus 2 square is minus 2 times minus 2, which will give us 4. I put my bracket there. I'm just simplifying it. I'm removing all these squares up there. Then I rule my line again. I can do all this one into 1. Minus 2 times minus 3 is 6. Minus is plus. This is 6. 6 times 2 is 12. So I have 12 now. So it's getting simpler. Plus, do this side. 2 square is 4 all over. This times this. 2 times minus 3 is minus 6. Then plus minus 2. I can just put my minus 2 there. Okay, so I'm okay here. So I continue at this side. 2 times 9 is 18. So I write 18 minus 4 all over 12 plus 4 over this times, minus 6 minus 2 is minus 8. This minus will affect this one inside here. So this is 18 minus 4. 18 minus 4 is 14 over 12 minus 4 over 8. I can reduce these fractions. So 2 here 7, 2 here 6, 4 here 1, 4 here 2. So I have it as 7 over 6 minus 1 over 2. So I can do my LCM. 6 and 2 LCM is 6. 6 into 6 is 1. 1 times 7 is 7 minus 2 into 6 is 3. 3 times 2, 3 times 1 is 3. So here 7 minus 3 is 4 all over 6. I can still reduce this one. 2 here, 2, 2 here, 3. Final answer, 2 over 3. So let's go and look for the option. 2 over 3 is B. So that's the answer. So I have on the board, still on the algebraic process. Find the equation whose roots are this plus half and minus 2 over 3. So this is clearly a case of get from the roots, go back to the quadratic equation. So normally they will say either x is equals to 1 over 2 or x is equals to minus 2 over 3. That's what this thing means, these roots. So I can just do it like this. X, when this one goes over, it becomes minus 1 over 2. Or x, when this one goes over, it becomes plus 2 over 3. So I'm going to multiply the two of them to get the equation. So I have x minus 1 over 2 times x plus 2 over 3. Now this is expansion again. You see how they are testing you. So I will multiply this by this and one instance, this by this another instance. So x times x is x squared plus x times 2 over 3 is 2 over 3x. Then again, this one will multiply this. I have minus 1 over 2 times x is minus 1 over 2x. And minus 1 over 2 times this will give me 2. Say minus 1 times 1 times 2 is 2. 2 times 3 is 6. Okay, so I have coefficient of x, the middle term, the two of them, can add them. So I'm getting closer to the answer. S squared plus. So these two, let me just quickly do the resolution here. Can I? Okay, let me do it. Let me do it here so you can understand. This and this, I want to find their LCM. So I'll put the answer here. So this and this, these two terms here. 3 and 2 is 6. 3 into 6 is 2 times. 2 times 1 is 3 into 6 is 2 times. 2 times 2 is 4. 4x minus 2 into 3 is 3 times. 3 times 1 is 3. Okay, so 4x minus 3x is x. So what I have here is x over 6, then minus 2 over 3. Now, all equals to 0. All equals to 0. Now, I'm looking at these options. It's not like this. So what I will do is to multiply each term by 6. Each of them by 6. So each term by 6. Let me write it there. Multiply each term by 6. Each term by 6. So first term, 6 into x, okay, sorry, x squared into 6, abi, multiply each term. Then second term, x over 6 into 6. Then minus third term, 2 over 3 into 6. Even 0 into 6 is 0, so I don't need to write it in full. So this one now is 6x squared plus, this will cancel, I have x, minus this will cancel, 2 here 1, 2 here 2, 4 is equals to 0. So I'm going to look for the option that rhymes with this answer. The option is, okay, is there a problem somewhere? Let me check quickly. Okay, so having looked at it, I see where what is wrong. And transferring here to here, I have 1 over 3 instead of 2 over 3, 1 over 3 here. So I'm multiplying 1 over 3 by 6. So I have 3 here, 1, 3 here, 2. So the answer here is 2. So this answer corresponds to this option, option D. All right, continue. Okay, so I have on the board number 6. It says make M such a formula of the equation. Currently, now the solution formula is y, but I'm going to make M such a formula. So I will just collect like terms, or let this term come and meet this term. So I'll say subtract both sides by c, subtract both sides by c. So I have y minus c is equals to mx plus c minus c. So this is the equation already. This is the equation. But what is now different is that both sides are being subtracted by c. Okay, so this is y minus c is equals to mx. This and this will become 0. C minus c is 0. So the next thing I'm going to do here is to divide both sides by x so that m can stand alone. divide both sides by m. So y minus c over m is equals to mx over m. Divide both sides by x, please. X. M is what we're standing alone. So this is x here, and this is x here. So that x cancel x. So finally I have m is equals to y minus c over x. So that's the answer. That's the new subject of formula. So go to the next question. So still on that algebraic process, we have this question. If 2 open bracket x minus 1 close bracket over 3 minus 3 open bracket 2x minus 1 close bracket over 4 is equal to half, find x. This is just a fractional case of a linear equation. The linear equation is an equation in which the highest power of the variable is 1. I have only one variable here, that's x, and the power is 1, highest power. So I'll write it like this: 2 open bracket x minus 1 close bracket 3 minus 3 into 2x minus 1 over 4 is equals to half. Now check this out. These are just 3 terms here. This is a term here, this is another term, this is another term. That's how you break it down, very simple. So, but what we'll do now is to find the LCM of this side of the equation. You have 2 sides of the equation. This is the left hand side and right hand side. Right hand side is just a constant term, and the left hand side has the variable that is x. We are finding x. We're looking for the value of x that makes this equation true, that makes this side and this side to be equal, to be the same thing. So what we'll do now is to find the LCM of this side. So I'll just roll my line like this. The LCM of 3 and 4 is 12. 2 into 3 into 12 is 4 times. 4 times 2 is 8. So I'll put 8 outside. Open brackets. Yes, open brackets. X minus 1. Then minus 4 into 12 is 3 times. 3 times 3 is 9. Open brackets. 2x minus 1, close the bracket, is equals to 1 over 2. Okay, at this point, I can expand the numerator. So expansion means that 8 times x is 8x, minus 8 times 1 is 8, minus 9 times 2 is 9 times 2 is 18x, then minus 9 times minus 1 is plus 9. All right? Okay, all over 12 is equals to 1 over 2. So I collect like terms. Of course, 8x minus 18x, then minus 8, then plus 9 all over 12 is equals to 1 over 2. So 8x minus 18x is minus 10x, then minus 8 plus 9 is plus 1. Of course, that is 9 minus 8 is 1. All over 12 is equals to 1 over 2. So I can cross multiply. So 2 can multiply numerator here. 2 outside into minus 10x plus 1 is equals to 12. 12. Okay, so at this point, I'll multiply this by 2, okay, and this by 1. So 2 times minus 10x is minus 20x, yes, of course. 2 times 1 is 2, is equals to 12. So I collect like terms again. At this point, I would say minus 20x is equals to, when this one goes to the other side, it becomes minus 12 minus 2. So minus 20x is equals to 10. All right, so x is equals to 10 over minus 20. X is equals to minus half. So the value of x that makes this equation true is minus half. And the answer is A, thankfully. So if you put x on this side as minus half, and here, we get this thing balanced. So we'll move on to the next question. Okay, so we have this one on the board. Again, it's still equation. Yes, equation. So it's in a fractional form, but this is a theory question. So we don't have the options to work with, but is fine. We're going to do this. So let's go. X over 2 plus 1 over x is equals to, change on to improper fraction. 2 times 1 is 2 plus 1, 3. 3 over 2. So I'm going to look for a common LCM for the three of them. These three denominators, 2x and 2. The LCM is 2x. So I'm going to multiply each term. Multiply each term. Multiply each term by 2x. This is another way of solving this thing. So what that means is that this term I multiply by 2x, this term I multiply by 2x, and finally this term I multiply by 2x. So I'll write it, I'll say x over 2, 2x plus 1 over x, 2x plus is equals to 3 over 2, then 2x. See, I'm multiplying each term by 2x. So 2 will cancel 2, I have x squared, plus x will cancel x, I have 2, is equals to 2 will cancel 2, I have 3x. So I'm going to be having a quadratic equation. So x squared, this one will go over and becomes minus 3x plus 2 is equals to 0. So this is a quadratic equation. So we're going to solve it in a quadratic form. So I will rule my line here. So I multiply this term by this term, first term and the last term. What I have is plus 2x squared. So I look for two factors that such that when they add themselves, when they multiply themselves, they will give you this. When they multiply themselves, they will give you this. When they add themselves, they will give you the middle term. So our two factors are minus 2x and minus x. Let's try it. Minus 2x and times minus x will give me 2x squared plus, because minus will be plus, and 2 times 1 is 2, x times s is s squared. So that one satisfies it. If I add the two of them, minus 2x plus minus x will give me minus 3x. I'll go again. I said I'll look for two factors so that when they multiply themselves, they will give me this term. And when they add themselves, they will give me the middle term. So these are the two factors. So if they multiply themselves, this and this multiply themselves, they give me this term. And when they add themselves, they will give me this term. So I'm going to substitute these two terms here I have here with the middle term. So I'll write this equation again. I'll write this equation. I will say x squared. So instead of having minus 3, I have minus 2x minus x. So I'm putting these two inside here, or for this one, then plus 2. So I will now factorize by grouping. So what's common in these first two terms? X is common in the first two terms. So I have x outside, x minus 2, minus what's common in this last term? I have 1, then x plus 2. Okay, so I will now factorize x minus 1 and x minus 2. So I'm taking this to 1. This one works. If this minus works with this plus, it becomes minus. So at this point, I will now say either x minus 1 is equal to 0 or x minus 2 is equal to 0. For the first case, x is equal to 1 and x is equal to 2. So these are the two solutions to the equation. So this is the solution. So either that I will put x as 1 here, and this will be true, or I'll put x as 2 here to be true. We can check that out. If I put x as 1 there, 1 over 2 plus 1 over 1 will give me 1 over 1 over 2, which is true. Or if I put 2 over 2 plus 1 over 2, it will still give me 1 over 1 over 2, which is true. So that's how you check in the exam. So I hope this video has been informative for you. I'd like to thank you for viewing.